Okay, so we're going to go through cosine law today. Now, many times it's shown to you as three different formulas. We're just going to memorize one version of this formula. And the reason we're going to do that is I find it personally easier just to rename a triangle rather than to learn 1, 2, 3 different versions of a formula. The three different versions are, just to give you an idea, in place of the c squared would be a squared is equal to b squared plus c squared. So all we're doing is changing the places of a and c throughout this. And then cos a. The other formula would be b squared is equal to a squared plus c squared. Minus 2ac cos b. And finally this one here. They're all identical. It's easier to just name the side or the angle in the triangle that you're looking for side C. Okay? That way, we only have to really memorize one formula. So what do I mean by renaming a triangle? First of all, we already know the rules with naming triangles that our angle and our side must be opposite of each other. So really, in this formula, it's just side A, and then there's side B, and then the two things you'll solve for it. This is a side, so either solve for side C or you'll solve for angle C. Okay? Those are the two things you're going to isolate in this formula. It'll be easiest to work with. So let's create a triangle here. Let's say we have some of this info here. So I have an angle here. Maybe it's 60 degrees. This side is 8 meters, and this one is 6 meters long. Okay? We want to find our unknown side here. Maybe its triangle is called R, S, okay, and T. So, if we want, you can replace all the letters in cosine law with R, S, and T. Or a very simple way to do this would be to rename this. We don't have to follow the letters that they use, R, S, and T. Now, since they're asking us for side T, the only side that's really important that we name is that we call T C for the formula that we're specifically going to use. So let's rename this side C and angle C. And then with A and B, it's kind of irrelevant. One named B and one named A. Oops, sorry, we did B in green, right? B and B. Okay. Now we can easily plug things in for our cosine law. So now that we know that, c squared, and that's our unknown side, is equal to a squared plus b squared minus 2ab times cos c. Okay. Side A is 6 meters. Side B is 8. 2 times side A again is 6. Side B is 8. And then multiplied by cos, and cos C is our angle of 60 degrees. Okay. So now all there really is to this is simplifying our right side of the equation, and at the very end we're going to have to square root it because we have a squared value on the left side. We're just trying to isolate C. That's the goal here, right? That's our side C we need to find. So let's quickly see if we can go through this. C squared is equal to 36 plus 64. Subtract 12, 8 is 96.
Yeah, the year I was born.
So wonderful. I'm just going to double check that to make sure that's right. 2 by 6 by 8. Yeah, okay. And then cos 60. In a second we'll multiply. 36 and 64, anyone know?
90, 100.
Yeah, that's right. Good. Okay. Now, here's the part where most students will end up making an error. They'll read this and see 100 minus 96 and equate this to be 4 times cos 60. This is not the case.
Isn't it like bed math?
Yes, exactly. It is bed math. So think of this like negative 96 times our cos 60. So let's solve our cos 60 and then multiply it by negative 96. Okay? Whoops, wrong one. So let's bring up our calculator here. 60 cos is 0.5 multiplied by the negative value of 96 equals negative 48. So this now reads c squared is equal to 100 minus 48. Okay? We essentially equated all of this to be negative 48. c squared equals 52. And we got to get c by itself. That's right. So we got to root both sides, which will cancel out the squared and the root over here. So we'll get c is equal to root 52. Is that what it is? Approximately 7.2 meters. Perfect. No. Don't write.
That's for the side.
7.2 meters. We've got it. Okay? That's solving for a side. Now let's use this information that we have. Let's say I want to find angle A. Okay? In this case. So we've made a new question. We'll call it theta. Our red theta in here. According to our cosine law, again, remember we named something C when we want to find that. So we're going to have to rename this triangle all over again. Okay? If you are able to switch the letters yourself, go right ahead and don't have any problem with that. So, like we were saying, we're going to rename this triangle again. So, to make it a little less messy, let's erase the letters we previously had. Okay? We still have our angles and our three side lengths. But this time, because we're solving for this theta here, I'm going to rename this so that this, again, becomes angle C and side C. So I can rename a triangle as many times as I like to suit my purposes. And again, let's call this maybe A and the other sides B and B. Okay. Now, when solving for an angle, what that means is we're actually going to have this measurement here, and we're going to have all of our side measurements. The angle is the only thing we're not going to have. Okay. Now, someone asked, can we use sine law? You can at this point. I just want to show you how to use cosine law to solve for an angle. Okay? So, what were they? A and B were 7.2 and 8, and 6 was C. Okay. So, I'm just going to write those down quickly. C is 6, A was 8, and B was 7.2. Okay. So, cosine law again. C squared is equal to A squared plus B squared minus 2AB cos C. Okay. Cos C, again, is what we're looking for. So we can replace that C with theta, since that's what we called it in our question. C is 6, so we have 6 squared is equal to 8 squared plus 7.2 squared minus 2 times 8 times 7.2 times that cos theta. All I did was replace all the side lengths. This will become 36 is equal to 64. Anyone know what 7.2 squared is? Top of their head?
51.
It should be almost 52. You're right. Let's see, because we did round. Actually, you're 100% right. We should just use that.
I think it's 51.8.
Yeah, let's round it to 52. Because originally that was the value we had for the other equation, right? We did a little bit of rounding, so we'll keep that in mind. Let's go back to our approximate 52. It's going to change a little because we're using 7.2 here, but that's okay. 7.2 multiplied by 8 multiplied by negative 2. Oh, I only did 7. Thank you. 7.2. There we go. Times 8 times 2 when it's negative gives us negative 115.2. So minus 115.2 times our cos theta. Now we can kind of collect all of these terms here. They're all adding and subtracting. So let's move 64 to the other side and 52 to the other side. And we're going to do this all kind of in one step here. 52 and 64 is going to give us 116. Yeah, when we move it to the other side, become negative. There's a negative 80. Perfect. So it becomes negative 80 over here. If you're kind of confused, just go through that quickly on your own. That leaves us with this here, negative 115.2 cos theta. Okay. Now, again, this is where some people make errors. Remember that this is multiplied by. So in order to isolate our cos theta, that's right, we're going to have to divide both sides by negative 115.2. Okay. What does that become on the left side? 0.69. Perfect. And then we get is equal to cos theta. Is that it? Are we done? Is the angle 0.69? What do we got to do? Cos inverse. That's right. When solving for an angle, we bring cos to the other side, so it becomes cos inverse 0.69 is equal to our theta, which is about 46, approximately 46 degrees. Perfect. So we've now used cosine law to solve for a side and an angle, and that's pretty much every reason we're using.